I start with you today's session with introduction to networking devices. So first of all, we would like to see the definition of the networking devices. So networking devices are physical devices that connect computers, servers and other equipments in a network to communicate and share resources. What is the purpose? It facilitates communication between various devices which are part of the network. It allows to manage, monitor and secure data flow, and it tries to improve network performance and reliability. These devices are very important in the sense that they are critical for setting up, managing and maintaining efficient and secure networks in home, in business environment and in large enterprises, maybe business enterprises or maybe academic institutions. So here today we will be discussing with you about switches. So what are switches? Switches connect devices within the same network. I will give you example in the next slide. So, and also in my previous term I have used this term switch, which is used to connect various devices in a network. Another very important device is there, and you might be familiar with this name, is routers. They connect different networks and data traffic basically. So routers are basically used to connect one network with another networks. So different networks can be connected via routers. Gateways serves as as entry and exit point of network. Say for example, if it is required to connect to different kinds of network. I mean to say different kind of network means, say for example, this network is using some other set of protocols while other network has been set up using other types of protocols. So in that sense, they are different in their working style. And if we want to connect these different kinds of network with each other, then the device which is used to connect these networks is known as gateways. Another device is there, and with which you are familiar with, it is modem. It converts digital data to analog for transmission over phone lines and vice versa. So modulator and demodulator, its full form is the modulator. It modulates, it changes the analog signal into digital signal and digital to back to analog signals. These devices are known as modems. Another device which we will be talking in the latter part of the discussion is firewalls. It protects the network from unauthorized access and threats. Another important device is access point, simply known as AP. So it provides wireless connectivity to devices in a network. And repeaters are the simplest one. They simply amplify signal to extend network range. Say for example, we have two devices and the distance goes beyond certain limit basically. So in between we can use repeaters. That repeaters basically amplify the signal and retransmit it further so that the data can reach to the destination correctly. So let us start with the first device, which is known as switches. So you just see here, this is the diagram of the switch. These things are known as various ports. So you see here, these are 8 port devices. 8 port devices means 8 computing devices can be connected with these switches with them. Say for example, one device is connected like that. This is one computer. Another computer you can connect like that. From this port you can connect another computer. From this port you can connect other computer. So with every port we can connect one computer or device, maybe device. So say for example, I am connecting here, it is printer. So one printer is connected with this port, and this printer can be shared by all the computers which are part of this network. This switch comes in 8 port switch. Here it is 8 port. If the number of ports are 16, then it will be known as 16 port switch. So depending on your requirement, you may have 8 port switches or 16 port switches or 24 port switches. There is further an provision to extend the network. Say for example, it is 8 port switches, and so maximum 8 devices can be connected from here. And say for example, we wish to connect more than 8 devices. Say for example, 15 devices we want to connect. Then this switch will need another switch of this kind, another switch again of 8 port, again of 8 port switches. So another 8 or 7 devices can be, remaining 8 or 7 devices can be connected from these with the help of these switches. And there is a provision to connect this switch with this switch. There is out and there is in port here. So out of this is connected with in of this port, and hence this switch becomes connected with the other switch, and the whole thing becomes the single network, basically local area networks. So now we will try to define what a switch is. A switch is a networking device that connects multiple devices, multiple devices within a local area network, and forwards data to specific devices based on MAC addresses. So here they work on the basis of MAC addresses. So MAC is basically address of the NIC card which is inserted over here. So every NIC card, network interface card. So whenever you want to connect any device with the network, we need to insert a NIC card, network interface card, with this device, and every NIC card has its unique number or unique ID. That ID is known as MAC address. So if this is having the, if this device, this computer is having the NIC, so whatsoever the number is there or whatsoever the identification address of this NIC is there, that is supposed to be the address for that computer as well. But in fact, it is not the address of the computer, but it is the address of the NIC card, which is part of this computer system, which is inserted. So whenever any device we want to have on the network, we need a NIC card, network interface card, and every NIC card is uniquely identified by a number which is known as MAC address. So here so whenever you want, any computer wants to send some information to other, that information is transmitted via MAC address. So say for example, this computer wants to transmit some message here over here. So it will come to the switch, and the switch say, okay, destination MAC address is this. So destination MAC address is this, then the message will be transmitted to this computer. If the destination MAC address for this computer, then the message will be transmitted to this computer. So I mean to say here that data forwarding takes place with the help of switch on the basis of MAC addresses. Types of switches, various types of switches are there. Some switches are known as unmanaged switch. So these are simple plug and play device, no configurations are required. So these kind of switches are there. Simply you can plug your computer from with the help of some cable and connector to these switches, and it will start working. So they are known as unmanaged switches. While there are another kind of switches which offers advanced feature like VLAN support, quality of service, monitoring and management of various devices, they are known as managed switch. So nowadays it is advised that we should use managed switch in the business organization or in our computer lab, like that. Another device type of switch is known as PoE, and provide power to connected devices over Ethernet cables. What are the functions? I have already told you that MAC address learning, it stores MAC address in a table for efficient data forwarding. So whenever it gets information from any computer, for any other computer, it checks what is the destination MAC address, and accordingly it transmits the data to that particular computer or that particular device which matches to the destination MAC address. They allow forwarding and filtering of the message. So direct data frame only to the intended recipient, reducing network congestion. Here, so whatever information is to be transmitted, they are simply forwarded. They are simply forwarded to the destination MAC address. What are the applications of these switches? These switches are used in offices, in the computer labs, data centers, and home networks for device interconnectivity. So say for example, if you want to have a network, or if you want to establish a network for 30 computer or 40 computer depending on your need, you can use switches of 24 port, one switch, another switch, and say for example, I am having two switches of 24 ports. So 24 devices, maximum 24 devices can be connected with one switch, while we do have another 24 port switch. So another 24 devices maximum may be connected with this switch, and later on what we will do basically to make a unified LAN, basically we will connect these two switches in this way. So out of 1 will be connected to in with 1, and thereby making the whole 48 computers part of the single LAN, local area network. How switches works, I have already explained over here. You just see here. So these are the switches, and these are the ports with the computers are connected, and whenever a packet is received in the switch with the destination address, it is forwarded to that computer, which matches to the MAC address of that computer. So a switch receives data frames from connected devices. It checks the destination MAC address in the frame. The switch forwards the frame to the specific port associated with the destination MAC address. If the destination is unknown, the switch broadcasts the frame to all ports. Sometimes it may happen that the destination is not known, means the message is broadcasted to all. So, every connected computer may receive that message, and if it is their use, they may keep it with them. Otherwise, they can simply ignore the message. What happens in the classroom basically? So, classroom attendance, we say roll number 1. That roll number 1 message is received by all the students which are part of the class, but only that student responds whose roll number is 1. So that is how the things operate over here. So full duplex communication allows simultaneous sending and receiving of data. It is not like that the data is flowing in one direction. Data may flow in both the directions. VLAN support, the switches allows you, the virtual LAN support enables logical separation of networks on the same switch. A spanning tree protocol, it prevents network loops in redundant topology. So these are some of the key features of the switch. Another device is there which is known as routers. So as the name suggests, it routes the packet through various networks. The device is being shown over here. This kind of device is there. They are simply known as routers. So a router is a networking device that connect different networks and direct data traffic between them using IP addresses. So they are not working on the basis of MAC addresses. The switches are working on the basis of MAC addresses. Here the routers works on the basis of Internet Protocol address, IP address. What is IP address? We will see, but the basis of their working is IP addresses. What are the functions for functions of router? It determines the optimal path for data packet to reach their destination. See here, I am just showing you a network. Say for the example, you see here some computers are there and they are somehow connected with each other. They form a computer network. Let it be this kind of situation is there. And say for example, this computer wants to send a message to this computer. You see here there is no direct connection between these two computers, but there are so many alternative paths available. Either the message can be transmitted via this way to this computer and from this to this computer. It will reach to the destination. This may be the one possibility. Another possibility may be that they may be sent to this way and from this to this way. This is the another available path. Another available path may be that the data is transmitted to this way, from this to go to this computer and from this to coming to this computer. So this may be, there are alternative paths which are available for transmitting the data from this computer to this computer. Multiple paths are there. Out of these multiple paths, out of these alternative paths, which path will be selected, that is decided by the routers. So the basic function of the routers is to determine the optimal path out of these available alternate paths to send the packet to the destination. So say for example, router decides based on certain conditions that this is the best or optimal path. Say for example, this is the best or optimal paths. So all the packets will be routed via this way. That is the function of routers. What are the various types of routers? So home routers are there. Home routers means it provides internet connectivity and local network management for home and small offices. So all of you might have seen that whenever you take some connections from BSNL, broadband connections or that, they provide you with the routers basically. And with the help of these routers, your device, your computer, your various devices, maybe mobile phones, your computer, your TV, may be connected via BSNL server through these routers. So these are known as the home router. Another type of router is known as core router. It is used in data centers and ISPs to route data with large networks basically. And I will see all these things in the later part of the example. And another is known as edge router. Edge router manages data traffic between internal networks and external networks. It is on the one edge of the that, and one edge is the terminal network, and in other edge, so many networks are there, external networks are there. Data can be transmitted via this way. These are known as edge networks. So what are the applications? I have already told you that basically they are used for routing the packets from one network to another network, or from source to destination. Internet connectivity, it provides internet connectivity. Network segmentation is there. Traffic management. These are some of the applications of the routers. You see here some examples of routers are given over here. These devices are known as routers. So this is router 1, this is router 2, this is router 3, and with the help of router various computers are connected. And you see here, when some message is coming from this point, this computer, it may be forwarded to this way or that way, unless and until it reaches to this desired computer. So several computers are connected. But here you see the important part is that I have already told you that routers work on the basis of IP addresses. So all the source address and IP destination address are mentioned in the form of IP address. And IP address, the format of IP address is like that. You see here, it is like that. Say for example, it is 192.168.2.1 like that. So in 4 octets it is there. If you convert it into binaries, then it will be 32-bit total address. So IP address 32-bit is length is there, and maybe logically divided into 4 octets. 4 octets of 8 bits, or 4 byte, whatever you may call it. Total 32 bits. And so if it is from 0 to so it is from 0 to 254, right? Similarly from 255, I mean to say 0 to 255, 2 to the power 8 and 2 to the power 8 is, and how many different combinations will be there? 2 to the power 8 means 256. So 256 different combinations are there for each octet. That's why I am writing 192, 168, 2, 1, or maybe 100, whatever there. So anything between under 255 is there. So from 0 to 255, the value of every octet may be from 0 to 255. But the actual values are always represented in binary, but for the human being it is easier to remember the things in this way. That's why you represent in the decimal notation and IP addresses. So the basic operation of the routers are that router examine the destination IP address of incoming packets. So whenever incoming packet is received by the router, they see which is the best path for this destination, and it forwards the packet to that selected path. So say for the example, it receives a packet over here, and it sees that okay, now which one is the best route to transmit this packet to the destination address. Accordingly, that packet is routed through the router. So that is the function of router. So it uses a routing table to determine the best path to forward the packet. It applies NAT to translate IP addresses for data passing between different networks, and can apply quality of service rules to prioritize certain traffics or certain types of traffic. So say for example, a lot of packets are received, 1, 2, 3, 4 packets are received simultaneously. But out of these 4 packets, it may happen that one packet is having the highest priority. Then rest of the packets will be stopped over here, and it will forward the packet which is having the highest priority. That is known as priority queuing or priority transmission. Routing protocols may be of, so all these happen according to certain rules and regulations that are known as routing protocols. So routing protocols are nothing but they are the protocols which are used for transmitting the message or finding the optimal path for transmitting the message from source to destination. The routing protocols may be of 2 types, maybe static protocol. Here predefined paths manually set by the network administrators are there. So if a packet is received for this computer, this is the path which has been decided well in advance and put in the put in the it is put in the network routing table. I mean, so all the entries are put in the routing tables. So the routing tables as having the predefined paths for this packet to the destination. If this kind of situation is there, then it is known as static routing. While dynamic routing allows you to change the routing decision based on certain conditions of the network or current condition of the network. Sometime it may happen that according to the routing algorithm, this is the best path for this route from this to this, but it may be that currently this route is very busy, a lot of congestion is there. If you will, though it is the best path calculated by the routing algorithm, but it may happen that at a particular moment of time this route is very busy. If you will transmit the packet, then it will take a lot of time. So better don't transmit the packet with this thing. Another path is available, so you transmit the packet via this way. From this way it will come to this way, and again it will reach to this destination. So though it may appear to be a longer path, but the packet will reach to the destination in shorter time because these are comparatively free paths. There is no congestion on these. So all such kind of decisions are taken by dynamic routing. Another important device is there, I have already told you, is known as gateways. So a gateway is a device that serves as an entry and exit point between two networks with different protocols. I mean to say, gateways are always used to connect to different kinds of network. Kinds means the networks which we are using different kind of I mean to say technology while they are being set up. Converting data into a format suitable for the receiving network. So here see this example is there. These are several computers and or a LAN is there. This is one LAN basically. You see here switches or hubs are there, and with the hubs various computers are connected. And here we do have another server. This may be part of any other network, and we want to connect these LAN with the server. For that we require a gateway basically. So gateway is there, and this gateway will translate the packet in such a way so that it could be understood by these computers of these network, because they are the different, they are using different protocols. They are the having different, I mean to say, meanings of the packet length and everything. So whenever a packet is transmitted from this to this network, it is translated by gateway so that it could be understood by the, or it suits or it follows the protocol of this thing. Similarly, if you are transmitting a packet from this to this network, then it will be translated in such a way, the packet will be translated in such a way that it could be correctly interpreted by the network on this side. So that is the function of gateways. So protocol conversion, you see here, translates different network protocols so that these two different kinds of network may communicate properly. This is just like whenever two persons are talking to each other. Say for the one person is knowing only Chinese language, another person is there who is very fluent in Arabic only. That person does not know Chinese and this person does not know Arabic. Still they can communicate with each other with the help of a translator. So translator is in between, and whatever message is to be given to this person, first the Arabic person gives the message to the translator, translator translates it into the Chinese language and passes it on to the next person, the Chinese person. Chinese understood it and reply backs in the Chinese language to the translator. Translator translates back to the Arabic language and gives it to the Arabic person so that they can communicate with each other. Similar kind of things are there. Similar role is there for gateways. So first thing is protocol conversion, that is translate different network protocol. Traffic management is another thing, control the flow of data between networks. And firewall capabilities, protects the network by filtering traffic. Sometimes it has another features as well, so that if you have defined that I will only allow this kind of packet, or I will not allow the packets which is having this kind of information. So this kind of filtering can also be done by the gateways. Whenever a packet is received which is violating the rule, it will be dropped at the gateway level. It will not pass on to the network. So this is these are some of the firewall capabilities like functions for gateways. Various kinds of gateways are there. One is known as application gateway. It manages specific applications. VoIP gateways are there, converts voice traffic between analog and digital formats. While cloud gateway they are there, which is used to connect local networks to cloud services. And a variety of applications are there. It may be used for interconnecting networks with different architectures, formats or communication protocol. So the two different networks which are different in nature, which are using different kinds of architecture, they are having different packet formats, different communication protocol, still they can communicate with each other with the help of the gateways, which acts like a translator in between them. Another device is known as repeater and extender. So a repeater amplifies or regenerates the signal to extend the range of the network. What happens whenever the signal travels a distance, as it travels further, the strength of signal gets weakened basically. So at certain point, it may happen that if you want to extend it further, and if you will not use a device to boost the signal or to amplify the signal or to regenerate the signal, what will happen? It will dies out. Dies out means the signal will become very weak and it will be very difficult to interpret the signal at the destination end. So just to save all these things, what we do basically, we use some repeaters, which repeaters are the devices which which amplifies or regenerates the signal to extend the range of the network. So signal boosting is the function. So it amplifies the weak signal to extend the coverage area of the local area network, and it minimizes signal degradation. What happens? I have already told you, the moment the more distance it signal travels, more degradation of the signals occur basically. So it reduces the data loss and improves signal quality, so that at the destination end signal can be or may be correctly interpreted by the destination computer. Various types of routers are there, repeaters are there, Wi-Fi repeaters are there. It boosts wireless signal to extend the coverage of wireless network. While Ethernet repeaters are there, they extend wire network signals over longer distance. Applications are there, it enhances signal strength in large buildings, outdoor areas or places with physical obstructions. Another device is there, hub. We have already discussed this device hub, that these devices are basically used to connect various components or various devices to a computer network. So a hub is a simple networking device that connects multiple Ethernet devices, making them act as a single network segment. It sends incoming data packets to all ports regardless of the destination. So it works in the broadcast transmission basically. So whenever some packet is received for any computer, it broadcasts to all the computers, and for which computer finds it suitable for them, they can simply receive it. Rest of the computers may ignore the message. Simple connectivity. It provides basic network connections without any intelligent data processing. So they simply allow, these devices simply allow different devices to connect with them so that they can work seamlessly as a computer network. Active hubs are there and passive hubs are there. Two types of hubs are there. So active hub basically amplifies and regenerates incoming signal before sending them out, so that we can have a better signal to interpret for the destination computers. While passive hub simply pass on the signal without amplification. Whatever signal is received, they are simply passed on to the destination computer. They are known as passive hub. No data filtering or intelligence is there with the hub devices, resulting in network inefficiency and sometimes collisions of the signals. So that whenever a collision occurs between the signal may get corrupted. So these are some of the limitations of the hub. That's why nowadays hubs are not used basically, and we do have a more intelligent device which is known as switches. So instead of hub basically, we are using, and with the advancement in the technology, the prices of switches are has gone very low. So instead of using hub, nowadays in most of the network installation, you will find switches in place of hub. What is the application? It is used in small networks for simple device connectivity through, though largely replaced by switches. As I have told you, they have been largely replaced by the switches nowadays. Another important device is there which is known as bridge basically. So bridge, as the name suggests, acts as a bridge to connect two or more network segment of the same network. Say for example, one network is there, you have another network is there, and you want to connect them to make a single network. Then the device which is used to connect these two networks is known as bridge. So a bridge connects two or more network segments at the data link layer to reduce traffic and extend network size. So you see, what are the functions? Traffic filtering is there. It filters data based on MAC address, reducing network congestion, and collision domain segmentation is there. So breaks up collision domain, improving overall network performance. What is mean by you see here a collision domain? So say for example, we have one network over here. This is the switch, and say for example 4 or 5 computers are connected with this switch and they form a local area network. Now we have another switch, say for example, and we do have some devices connected with this one. This is another LAN, and if we want to connect these two LANs with each other, one device is there which is known as bridge. So bridge is nothing but switches like device. You can connect these two LANs with the help of bridge. This kind of device is there, bridge. Then and thereby making the whole network as a single network. Now instead of two, we are having, whenever you are connected these two local area networks with the help of LAN, it becomes a single LAN. It starts working as, but the important thing is that they have different collision domains. Collision domains means if two computers start communicating over here, I have already told you that in the bus topology, what happens basically, in the bus topology, what happens if two computers start communicating simultaneously, then what will happen? The signal will collide with each other and the signal will get corrupted. So here in this case basically, if two devices of these networks starts simultaneous transmission, that only the collision will occur, collision will be affected by this switch only. It will not affect the operation of this network because it filters the traffic, it segments the collision domain. So collision domain is segmented. Though the whole network, though it is working like a whole network, but the collision will, if collision occurs, that will affect that particular network, that particular subnet you can say, where the collision is taking place. It will not affect the operation of the whole network. That is the meaning of collision domain segmentation. So, okay, two types of bridges are there. One is known as transparent bridge, another is known as source router or source root bridge. So, transmission or transparent bridge operate without being visible to network devices. So, it will appear to you that the whole network is the same basically. There is no in between devices. That is the meaning of transparent. While source root bridges use routing table to forward data packets. So if this kind of another kind of bridge is there, they maintain this kind of routing table. If the information is to be transmitted from this to this computer, so here it maintains a routing table over here, and accordingly the message is transmitted to different networks through which it is connected. Application, if we talk about the application of bridges, then it is used to extend networks and connect different network segments with similar protocols. These two segments are there. This is segment 1, this is segment 2. We can connect via bridge and it becomes the whole one network, right? So that is the device which is known as bridges. Now we will discuss something about network interface card. I have already told you that whenever you want to connect your computer or your any device to the network, we need a particular device which is known as network interface card. So here is the network interface card, and every computer has a slot to put in this network interface card or to connect this network interface with the motherboard of the computer. So whenever you want to, sometime the computer comes with the inbuilt NIC, and sometime the computer is not having that NIC. In that case, you will have to purchase this NIC and you will have to put on the computer if you are interested to put your computer on a network, or if you want to connect your computer with through any internet or networking environment. So this is the, and I was talking about this NIC, which every NIC, though inbuilt NIC or external NIC, have a unique address that is known as MAC address. Every NIC. So every NIC in the world is having, and it is a 48-bit address. Just like IP address is a 32-bit address, it is 48-bit address. So 6 octets of 8 bits. 6 octets of 8 bits. So 48, 8, 8, 8, 8, 8 and 6 bits of 8 octets. That is the format of and all are in binary numbers, all in binary numbers. But as I have told you that it is difficult for us to remember the things in the binaries. So we try to convert it into the decimal notation, and decimal notation I have already told you that with 8 bits it may be like that 1 1 1 F 1 A 2 C and like that, because 0 to 9, but here we require something more. So for 10 we use A, for 11 we use B, similarly for 12 C, 13 D, 14 E and 15 F. So 15 F. So this kind of things are there. And this is the format of, basically this is the format 1 2 3 4 1 6 1 2 3 4 5 and maybe 1 D. This is the format of the MAC address in decimal notation or in octal notation, whatever you may call it. Fine. So what is NIC? So NIC is a hardware component that allows a computer or device to connect or to be connected with a network. So whenever you want to connect, and this is the jack, basically it is known as RJ45 connector. So with the help of RJ45 connector, you can connect your computer to the switch. In another end, what is the sir? Here is, you have the switch basically. So one end will be there, another end may be connected with the switch. The moment you connect your device with the switch, your computer gets connected with the local area network. So, okay, coming on to the definition of NIC. NIC is a hardware component that allows a computer or device to connect a network. What are the functions? Physical layer connectivity. It provides the physical connections to a network. So through wires and even wireless media, you can connect your computer to the network. And it handles data encapsulation, addressing and error detection related jobs. Two types of NICs are there. One is known as Ethernet NIC. For wired networks, we use Ethernet cables, and this kind of device is there, which is known as Ethernet NIC. And for wireless network, which uses Wi-Fi signals to connect, they are known as wireless NIC. What is the application? It is required for all network devices, from computers to server to IT devices, if they want, or even printers if they want to be connected to the network. So one NIC card will have to be inserted. They may be inbuilt or they may be the external devices. Then only it will be possible to connect these devices through the network. Another component is there, we next cables. If you are talking about wired networks, fine. So I have already told you that these are various kinds of cables. They are known as twisted pair. Twisted pair cable. You just see here two pairs of wire, copper wires are there, and they are twisted in the helical form. So you just see here twisted pair. They are used for establishing local area network. You just see here another type of cable is there, which is known as, so various types of twisted pair cables are there. They are known as category 5, category 6. So they are basically various types of cables which are used in Ethernet LAN. Whenever you want to connect your computer or you want to establish a local area network, most of the time you are using this cable, which is known as Cat5 cable or Cat6 cable. Another type of cable which is having more bandwidth, I mean to say, which can carry more information at a faster speed, which is known as coaxial cable. Coaxial cable. You just see here, this is the cable, sir. This is the copper cable, and above the copper cable we do have a PVC material. PVC material is there. Over that we do have a mesh, and again we have PVC coating over here. The actual information is being transmitted through this copper conductor, and they have the higher resistance, or they have the higher immunity, I mean to say. If any external signal wants to disturb it, they cannot disturb. First it will be prevented by the external covering, then it will be resisted by the mesh, then it will be resisted by the so I mean to say they are very much immune to any external disturbances, and they are basically used for cable TV transmission in metropolitan area network, in campus area networks, for high speed data transmission, or in the backbone of local area network, you can use these cables. They are known as coaxial cables. They are a little bit on the higher side as far as the cost is concerned, right? And the most importantly and very powerful cable, you can say, in terms of high speed data transmissions and security, is the fiber optic cables. Fiber optic cables. You just see here, these are the various fiber optic cables are bundled in the form of a cable. So these are the fibers. You see, these are thinner than hair basically, and electrical signals, electromagnetic signal can be transmitted via this way through the pulses. Light pulses are there. So in the form of light pulses, the signals are transmitted at a very high speed. So you just see here, and this is the brief of all the types of cables. Twisted pair cable are there. They are used for Ethernet connections. Coaxial cables, as I have already told you, that used in cable TV and broadband internet, and for having a campus area network or metropolitan area network. And fiber optic cables are used for high speed data transmissions over long distances. So these are the very short description about the network cables. Now another thing comes in the picture is known as connectors. I have already told you that you see various kinds of connectors are written over here. In the previous thing I have shown you, you just see here this kind of port is there, and here it uses which kind of connector? RJ45 type of connector. So a cable is there, say for example this cable, Cat5 cable is there. At one end we do have RJ45 connector, and another end we have RJ45 of connector. So RJ45 connector, it is RJ45 connector. So one end is inserted over here in this place, and another end is inserted in the switch, and it is also RJ45. It supports RJ45 connections. So this way these two devices may be connected to the network. So you see various kinds of connectors are there. RJ45 connector is a standard for Ethernet connections. Whenever you want to establish a local area network, you can use RJ45 connectors at both the ends for connecting the interface card as well as to the switch basically through the cable. And the cable will be twisted pair, Cat5, Cat6 cable will be there. BNC connectors are there. They are basically used with coaxial cables, BNC connectors, and this kind of connectors are there. You just see here, and these kind of connectors are there known as BNC cables. SC, ST, LC type of connectors are used with fiber optics. They are the connectors which are used for the fiber optic cables basically. So proper cable and connector selections ensures optimal network performance reliability. So what kind of cable you are using, accordingly that kind of connector will be used depending on the ports which are available on your devices, or according to which kind of ports your devices supports, I mean to say. So these are the discussion about network connectors, and with this basically we finish the discussion on various kinds of network devices, where we have seen what do we mean by switches, hubs, routers, bridges and gateways, and we have also seen the functions of various kinds of connectors, cables, various types of cables and connectors. I hope you might have enjoyed this session. Thank you very much.